Hello everyone, in this video I'm going to show you how to install Proteus in Windows. And this program supports Windows X from Windows XP to Windows 10. It can run on both 32-bit and 64-bit. Proteus is the best software for designing common circuits like digital circuits and electrical circuits. And after that you can simulate your circuit uh, and in that project you can find your bug and fix it. And also you can print and you can also print a drawn circuit into the paper, whether on A4 or A3 or A2. You can choose in that program. Before running a setup file, you need to click runtime and click setup to uh, install the pre-requirements item. Click next. You need to wait to install the runtime of that program, and after a while it will finish. Click OK. After finishing, this dialog will be shown and it says the installation is complete, and click finish. And after that go to backside and click setup. And also I will upload these files into my cloud center, and you can download it from below that I will link, and you can download easily. You can download it very easily. Okay. Next, you need to wait to finish. Once finish, click finish, and we are ready to start our program. In this section, we will write a simple example. We want to simulate the AND gate function for creating project, and click file, new project. Here you can browse, select the path for the project. For example, here let's name as 1, and we create design template as a default. We choose as a default. Next, don't need here, finish. You need to draw all of the components inside of the blue border. In here we click oh, unfortunately we got this error. If you get this error, for fixing solutions is this: close the program, right click the Proteus Professional, open file location, In here, PDS right click, properties, and in this section, check the run this program as an administrator. Click OK and click OK. Close this one and run the program. Wait to load. You can open the project from this section, or you can open the project from here. If you click this one, it directly runs the program. We will try it later. You select this, and now the error has fixed. In here, we can see lots of component devices in this section by typing the name of the device. For example, 7408. That is the name of the AND gate. And 7400. It's the NAND gate. And also I mentioned in my page that I showed us some logical devices and or not with IC code. You can see in my Instagram page. For example, 7402 it's NOR gate, and 32 is OR gate, and 7486 is XOR gate, 266 is XNOR gate, and also lots of devices you can see it. For example, 74 I think that it's a multiplexer, one of four. It has 4 input and 2 selectors, and this one will be connected to the GND, and these are the output. We will give an example in next videos. First, we want to try this function AND gate, and we need the logic states. With this we can change value 0 to 1 or 1 to 0. We click this, and logic probe the result of the function, and that it shows it is 0 or 1. We click this and click OK. We need to draw in, for example, in here, and it's AND gate. Logic, we need to logic state. By clicking the mouse, you can change it value 0 to 1 or 1 to 0. You can right click and edit properties and give a name as A, and this one as a B. You can also right click and drag object and move this object to anywhere that you want. We need the result, and we put it here and give a value as F. In this section, as you can see the red square, little square, and at that point you can start pressing mouse and clicking mouse and move the mouse toward to that logic state A, and you can press the mouse to look like this and this. By clicking mouse, it can release drawing. By the way, you can redo this for the B. We connected the result to the F, and we're ready to start the simulation. Before that, we know that let me remember the AND function. AND function is like this. This is A and this is B and this is F, and the truth table is like this. Zero zero 0 1 1 0 1 1. AND of 0 and 0 will be 0. AND of 0 and 1 will be 0. AND of 1 and 0 will be 0. 1 and 1 will be 1. And you can consider as a multiply. For example, 0 multiplied to 0 will be 0. 0 multiplied to 1 will be 0. 1 multiplied to 0 will be 0. 1 multiply 1 will be 1. You can consider like this, like a multiply function, and AND function looks like the multiply function, and this is the truth table of the AND function. And we are ready to simulate. For simulating, you need to click this button that labeled run the simulation. Click this, and you can click in this section. You can click by mouse to change the value 0 from 0 to 1 and 1 to 0, and this one you can click 1 to 0. According to the truth table 1, the result will be 0, and this again, this will be 0, and if I change it to 1, the result will be 1. And this is the example of the AND function. And also you can insert the LED lamp instead of this logic probe. For that, we click in this section, we click P sign, and we search for the LED blue, or you can search for it has blue, red, and green. For example, green. Select the green and remove this one, and we put it in here, and we right click, and the part reference will be F, and we connect it to the here. Don't forget you must connect a wire from another part of LED toward to GND. For finding the GND, we go this section, terminal mode, and we select the GND and double click it. We click and click the mouse, and it will be shown like this, and by clicking the mouse again it will drop the GND sign, and we can select the edit properties, and we can rename as, for example, GND, and we connect it by this to this section. Now we simulate again. Again, the 0, 0 is 0, and also 0, 0, and the lamp will be turned on. Also, you can try the LED blue or red, and we have almost 3 LED lamp in this section, and we can find it lots of device in this section, and you need to click P. You can search for the keywords to find lots of the device in here, and also in this software you can design your own block, and that I will teach in the next videos. Okay, I hope to enjoy my videos, and thanks for watching. See you on next videos.